Hello, today we are going to mention one of the most common activation function, hyperbolic tangent, and this function is also called as Tanh function, and actually it's equal to sin h over cos h. Sin h function is equal to e to the power of x minus e to the power of minus x over 2. Similarly, cos h function is equal to e to the power of x plus e to the power of minus x over 2. Let's put these values here. E to the power of x minus e to the power of minus x over 2 over e to the power of x plus e to the power of minus x over 2. We can remove over 2 values and Tanh value, Tanh function is equal to e to the power of x minus e to the power of minus x over e to the power of x plus e to the power of minus x. I wonder the derivative of y with respect to the x. But before that, please remember quotient rule. Quotient rule. It says if a function h can be expressed as function f over function g, then we can calculate the derivative of function h like that. Derivative of f times function g minus derivative of function g times function f over function g squared. Let's apply this, but before that I need to calculate the derivative of sin h and derivative of cos h too. E to the power of x over 2 derivative would be equal to e to the power of x over 2, and e to the power of minus x's derivative is also e to the power of minus x, and its multiplier over 2 term remains same. But we need to calculate the minus x's derivative here, and it's equal to minus 1. And multiplying minus 1 times minus 1 would be equal to plus 1. That's why derivative of sin h would be equal to e to the power of x plus e to the power of minus x over 2. Notice that this is equal to cos h value. Similarly, cos h value's derivative would be equal to sin h. Let's prove that. A to the power of x minus 2 over 2, sorry, its derivative is equal to e to the power of x over 2 and plus e to the power of x's derivative is e to the power of x times minus 1 over 2. Now this is equal to e to the power of x minus e to the power of minus x over 2. Notice that that's the actual value of sin h. In other words, derivative of sin h is equal to cos h, and derivative of cos h is equal to sin h value. Now we can apply a quotient rule to find the derivative of tan h value. I need to find the derivative of this term. Find derivative of sin h times cos h minus derivative of cos h times sin h over cos h squared. Let me clear this part or table. Remember, sin h this derivative is equal to cos h times cos h, means cos h squared, and cos h is this derivative is equal to sin h, and sin h times sin h would be equal to sin h squared over cos h squared. We can separate these values as like that: cos h squared minus a over cos h squared minus sin h over cos h squared. This is equal to 1, and sin h over cos h value is equal to tan h. I mean that derivative of y with respect to the x, in other words, derivative of tan h with respect to the x is equal to 1 minus tan h squared. And notice that tan h is the y value. That's why we can express this as 1 minus y squared. Please remember that demonstrating derivatives easily is the first condition, and calculating them is second one. These preconditions or these prerequisites makes activation functions common, and as seen, derivative of hyperbolic tangent is easy to demonstrate and easy to calculate. And the function graph would be like that. Its maximum value would be 1, and its minimum value would be -1. Thank you for watching, and see you next time.